That was great. Thank you, Devin, also for starting all on your own on time. I love it. Our next student is Mitchell Gallerstein from San Pasqual High School. And Mitch came here for a tour one day. And I give tours all the time. And I only see the reaction I saw in Mitch's eyes every once in a while. So it's always exciting when one of those students gets to come back. He's going to tell us about his summer in organic chemistry. Turn off. How do we turn off? Can we just close and then shut off? Or let's see. Can you close the, actually close the PC? Cool. Cool. And Mitch is not doing a PowerPoint. He's going to teach us chem.
All right, guys, so my name is Mitch Gallerstein, and this summer I interned at the Baran Lab, which is a total synthesis organic chemistry lab. Basically, total synthesis is you start with a very basic molecule that you can buy from a drug supplier, and you turn it into something really crazy. So I did two reactions this summer. The first one was the attachment of an aryl group, which I will draw right now. All right, so this is a benzene ring. This is a very important ring in organic chemistry. This is a oxygen and a methyl group, which is methyl CH3. So that's this. This is what I was attaching to my reactions. One of the most important molecules that I used for this reaction is called chromone. The structure of chromone. All right. This molecule is so important because you can make something called flavones with it. And flavones are actually really important in medicine. They're used for osteoporosis, diabetes, and cancer. They can all be, I guess, treated through these. So you take this and you attach it right here. That goes there. And that's a flavone. So basically, this is the first reaction I was doing this summer. The second reaction I did was the attachment of a trifluoromethane, which is trifluoromethane, and then there is an H down here, but that's where the H would get cut off and it would be attached to my molecules. The molecule that worked the best for this reaction is called theobromine, and for those of you guys who don't know what it is, it's actually an ingredient in chocolate, and that's the ingredient that is toxic for dogs. So whenever you hear somebody say that chocolate is toxic, it's actually the theobromine. So this molecule is actually a lot like caffeine, which is another molecule that works really well for this reaction. And the reason that a CF3 reaction is so important is because drugs get metabolized in your body, and the slower that you can get them to metabolize, the less pills a person has to take, and that means the less drug you actually have to make, which eventually saves money for the company and is better for the person because they're taking less drugs. So it's kind of a big molecule. All right, so this is theobromine. So basically, what I would do is I would set these reactions up. I would let them sit overnight. The next morning, I would come in and I would TLC them, which stands for thin layer chromatography. Basically, all TLCing is it's a sheet of glass with silica gel on top, which isn't actually gel. It's a white powder that's really finely ground up glass. And so you put it on top of there, and it acts like chromatography. The liquid runs up the plate and it brings your molecule with it. You usually use a solvent. The more polar the solvent, the higher your molecule goes. So I'd run a TLC. Sometimes I would get 2 dots, a starting material in a product. Sometimes I'd get like 7 dots, and we have no idea what it is. So after TLCing it, I'd normally take it to an LCMS, which is, it's a liquid chromatography mass spectrometer, and that basically gives you a visual of if your product's in there and how much is in there. So if there was a good amount of product in there, the next step would be to take a crude NMR. So I would run that over to the NMR machine. Okay, and for those of you who don't know what NMR is, it's basically a MRI machine. It does the same exact thing, except in the, I think it was in the 60s, when they first came out with this, people were afraid of the word nuclear magnetic resonance, so they had to change the name to MRI for human use. They kept NMR for scientific use. So I take a crude NMR, and we look at that. If it looks like I had product in the crude NMR, the next step would be to run a column, which is basically, it's a TLC, but reversed. So instead of your product running up, your product runs down. And so that separates your product into a different, so you have your product separated basically, and then you'd rotovap it down, and that's when you take your final NMR, and from there, you're basically done. Unless you're putting it in a paper, then you have to purify it some more, and then run more NMRs. So that's basically what I did this summer. This summer was actually the first time I had ever done organic chemistry. The first time you take an organic chem class is your freshman or sophomore year in college. So I was completely new to this. I learned a ton. I learned a lot about laboratory practice. I learned a lot about just organic chemistry in general. There's a lot more to it than what I was shown in school, and there's a lot more to lab life than I thought too. It's crazy the hours that the graduate students work. And this internship really just reinforced that science is what I want to do. And yeah. Thanks, guys.
I once heard a graduate student joke that chemistry was drawing lines and numbers. And Mitch, you did a really good job. Congratulations. Our next presenter has been working in the Kelly Lab. Please welcome Jason Gao from Mount Carmel.